Okay, here we go. Section 4.9. Solve by graphing. But it's not the same graphing we're doing. So, here's what we do. Step number 1 in doing these type. Notice there's no y, it's now 0. So basically y is 0 in this case. But step number 1, find the x-intercepts first. What ways do you know how to find x-intercepts?
Completing the square.
Complete the square, quadratic, factoring, and then solving if you want to. But the easiest way for this type of problem is actually use your calculator. Okay, so everybody get out your calculator. Let's save some time because your answers can be in decimal form. So these answers, x-intercepts, make them approximate answers. I don't want this answer, 5 plus or minus square root of 2 over 7. I don't want that now. I want the approximation of that, okay? So you could do it by hand and do all that, but easiest, let's put it in the calculator. Put that quadratic 2x squared plus x minus 4 in your calculator. Go for it. 2x squared plus x minus 4. I'll put it in mine as well. 2x squared. Oops. Plus x minus 4. Hit the graph key. What are we going to be looking for?
Zeros.
The zeros. Remember all the different ways to say it? X-intercepts are zeros. So remember how to do that? I'm going to show you again. People forget the boundary stuff, so I want to make it very clear right now. Save you some time. Second, calculate up here. Hit number 2 for 0. Now, how do you do the left boundary, right boundary? Half the people know, half the people don't. So you have to focus on one of the points you want. Here's a 0 right here, which means I want to make a boundary to the left of it. So pick anything to the left of it. What number would you pick to the left of my point right here? Pick a number to the left. What? -3 would work. That's right here, right? -3 is right here. So type in -3, press enter. Look what it does. It gives a little arrow right here. That means starting here to somewhere else, it's going to find a 0. So you have to make a right boundary. That's what it's asking for now. Where is your right boundary? You pick one.
5.
Okay, now be careful. If you pick 5, which is over here, you have 2 points in the middle. You don't want 2 points. You want to be specific. You want to pick from here to here, and then it'll choose this one. Then when you do the other one, you want to pick from here to here, and it'll choose this one. You have to do one at a time. You understand?
Yes.
Okay, go ahead and get this one. Pick a right bound. What number would you put in?
0.
0. It'd be easy. 0, enter. Then it has guess. Notice my 2 little triangles. Between here and here, it wants you to pick a 0. Yes, guess. There it is. Notice how it blinks right on it. 0 is -1.686, blah, blah, blah. I want 2 decimal places. So therefore, my 0 is -1.69. I get some people who still aren't rounding correctly. Please understand how to round. Okay, I marked off a bunch of points for rounding errors. If I want 2 decimal places, you look at the next one, 6, which rounds the 8 up to a 9. Okay, write that one down. You go get the other one by yourself. Go. Get your zeros here. Get your other one. Make a boundary. So second, calculate 0. Pick a left boundary to the left of this one, which is 0. I'll pick 0 in this case. And notice it puts a mark right here. And then I'll make a mark to the right, which I don't care. 3, 4, 5, doesn't matter. 3, enter. Puts a triangle up here. Between here and here, it's going to pick a 0. It's going to land right there. Enter. 1.19 if I round correctly. Write those 2 numbers down on your paper. Here we go. So, number 1, I wrote it down, find the zeros. They were 1.19 and what? 0.69. Okay, those are my 2 zeros. Step number 2, put those zeros on a graph. So put those on a graph. So everybody draw a normal graph. Space it out a little bit. 1, 2, 3, 4. 1, 2, 3, 4. Just make it quick. What's nice about this question, these graphs do not have to be exact. You know your first question we did last time? Those graphs where you have to shade, I want those graphs to be exactly the way they're supposed to be. This graph right here is a sketch. Alright, so put those on a graph. Let's put negative 1.69 is somewhere around here. Put a dot. 1.19, about 1.2, somewhere right around here. Put a dot. Now, the next step, actually let's just put it under step 2. We'll say sketch the curve. Which means all you have to do is look at your calculator and say, actually you don't even have to look at your calculator. Is this thing going up or down? You can tell by the A. It's going up, right? All I have to do is this. I don't care if it's shorter, longer. If it's going up, just draw something like this. This is a sketch. Please don't go and get a bunch of coordinates and draw the coordinates in here, because it does not matter. Okay? We're using this to get our answer. Okay? Here we go. Sketch the curve. We did. Step number 3 is actually just interpret your results. Here's where people struggle, right here. Try to understand me when I do this, okay? Alright. Actually, I should do it on here because people are watching this. So, what does this say? This thing, when is this greater or equal to 0? Try to follow me here. This whole thing represents the curve, right? This thing represents this right here. So tell me this. When is this greater than 0? You know what I'm asking you? When is the function, when is the curve greater than 0? I'm going to highlight it for you. You see this? Basically it says, when is the curve above the x-axis? When is the curve positive? That's what this is saying. When is the curve positive? Right here, right? This is positive. All these y values are positive. And all these y values are positive. You understand what I'm saying? All those y values are positive. No, but that's not what the question's really asking. The question's asking you, what are the x values that make it positive? That's what the question's really asking. What are the x values that make it positive? Can you point to the x values that make it positive? What would make it this part right here? Which x values? These ones? These ones? These ones? Yeah. These x values would create positive answers. These x values would create positive answers. Now all you have to do is tell me what those answers are. What is this right here? X is greater than, because it's to the right, what? True, equal to 1.19. It's going this way, so this is a or. X is less than or equal to negative 1.69. This is why we have to name our x-intercepts. These actually are not called they are called x-intercepts. They're also called critical points. These are our critical points right here, our x-intercepts. Okay? So number one, find your critical points because those are going to be the ones in your answer right here, your critical points. This is the final answer. If x is greater than 1.19, if I put an x value greater than 1.19 in here, what do you think would happen? It would satisfy this inequality. It would make it greater than 0. If I put something in less than negative 1.69, guess what? It would make this greater than 0. This takes a couple for some people. Some people can get this right away and say, okay, I understand, I'm good. A lot of people, your thinking isn't inclined to this type of thinking here. You got to take a couple to do it. So, find your critical points, sketch your curve, up or down, and then just say, okay, when is it greater than 0? Oh, right here and right here, which means these are my x values, these are my x values. Put that right here. Let's do another one. Any questions before I make you do another one? To sum up, to clear up anything that's on your mind right now. No? Okay.
Is this only when it's like greater than or equal to or less than or equal to 0?
If there was a y there, we would shade inside or outside. So when it's greater or equal to 0 or less than or equal to 0, we just decide what. Now we're just shading the x-axis because all we want are x's, right? That's why we just shade the x-axis.
There's no difference if it's just greater than, right? Then we just put like it's greater than or less than, right? If the problem up
if this was different, if this was less than, what would change? Yeah, if it was less than, when is the function less than 0? Look at it. This is below the x-axis. It's less than 0 here. Which means, yeah, which means it's here. Which means it's this and this. Put them together. Yep. That's it.
2 questions. Do we have to show you the graph?
No, I'm not going to worry about that.
What if y is 2 or negative 4? It's not 0.
Oh, good question. So if this over here was not 0, then you would make it 0.
Okay.
Yep. That's your question? Yeah. Make it equal to 0. Not equal to, but less than or equal to 0. Okay, good questions. What else? Somebody have another one over here? Okay, got it? Let's try one. Let me give you one. So scratch this out. Solve this one by graphing. Let's see. Negative 2x squared minus 7x greater than 4. Solve this by graphing. Same method. What do you do first though? Yeah, subtract 4. Make it equal to 0. So let's find our critical points. Just tell me what they are. X equals what? 2.78 and 2. Okay, draw your graph. So negative 1, 2, 3, 4 is good enough here. Negative 0.72 about somewhere here. Negative 0.78 about here. This graph is going down. Look, I didn't have to look at the graph. Look, there you go. I know that's not even the graph. That's might look kind of like it. Doesn't matter. The graph leads us to our answer. Now here's the question. When is the function? See, here's the function, right? When is this function greater than 0? Some people caught that, some people didn't. And that happens every year. So here's the deal. You look above the x-axis or you look below the x-axis. Where do you look in this case? Above, because greater than 0. So basically this. When is the function, which is this, above the x-axis? Right here, right? That part right there. So here's the real question. What are the x values that make it greater than 0? Right here. These x values right here make it this part right here. These x values on the right make it this. These x values on the left make negative y values. These values right here make positive y values right here. That's the best I can do. I don't know what else to say. Okay? When is it positive? Right here. What are the x values? These make it positive. All you have to do now is interpret your shade. This shade is between this number and this number. You have to write it like this. Negative 0.72 on this side, negative 2.78 on this side. X is between these two. Now, how do you know it's not equal to here and here? It all depends on this right here. This is not equal to, which means these aren't equal to. The next method is called just algebraically. So I'm going to say this. Solve this algebraically. Same question, different method. Okay? Different method. Here's the method. Number one, you do the same idea as before. You find your x-intercepts, but make sure they are approximate if need be. Approximate. Alright? Use your calculator. That's the easiest way. Or if you want to use quadratic formula, that's fine too. No problem. It takes longer, but no problem. So go ahead and do that. You start it off. Find your critical values right now. Okay, what are those points? Give me one. Anybody? Negative 3? 5. Those are your zeros. Here's step number 2. Instead of putting that on a graph, we're going to just put it on a number line. So step 2, put those on a number line. So draw a number line. People like this method better because it's easier to understand. But the other method, if you understand it, is actually quicker than this method. So let's draw this. Okay, put 2 dots on your number line. Negative 3 and 5. What you're doing at this point is doing this. We're going to make boundaries. We're going to make regions out of these 2 points on a number line. So here's your next step. Make 2 boundaries. Draw 2 lines straight down through your points. Put those on a number line and make boundaries. Boundaries. Alright? Now, once we made the boundaries, what we've made is 3 regions. Region 1, Region 2, Region 3. So what could we do? What did you guys say before? What did you want to do to check? You wanted to test some points, right? That's all this method is about. Testing points. So basically what you're going to do is you're going to test this side. Does this side work? Yes or no? Does this work? Does this work? So let's do this. Step number 3. Test a point in each region. So let's go to the left-hand region up here. What point would you want to test?
Negative 5.
Okay. Did either of those matter? Negative 5, negative 4. Doesn't matter. Anything in here. What about negative 3? That's right on the boundary. You don't want to test that. That doesn't do anything for you. So test negative 4 or negative 5. So test negative 4. What about in the middle? What would you test?
0.
Okay, in the middle, we're going to test 0. And let's see. On the end, we're going to test.
6, 7.
Doesn't matter. Either one. Test 6, 7. Doesn't matter. Okay, here's what I want you to do. I want you to plug those 3 things in where? The original, to test to see if they make it true or not. So test 0 in the original. So 0 squared minus 2 times 0 greater than 15. What do you think? Yes or no? 0 is greater than 15? No. That means these are not my solutions. I put an X. Okay? You test the other 2 to see if they're true or not. Go ahead. Here we go. Final answer. You tested this side. It was true. You test negative 6 or positive 6. You put it in here. That made it true as well. So you could shade this, you could shade this, which mean my answers are x is less than negative 3, yep, or x is greater than 5. This is what I'll be looking for on the line. I won't be looking at this. You do what you want with this. Okay? Let me give you one to practice and try it out. Okay, number 4. I guess there's 4 things. 3, test a point so that you can, number 4, interpret your results. Once again, you choose which method you want to use. I like the other method because it's quicker. This you have to keep testing, which is fine. No problem. Okay. All right, section 9 is done.